Okay, guys. So regarding IoT security, that's the part today to be discussed. Perhaps IoT systems, as they are, let's say, constrained computer systems, they tend to have quite similar problems like your PC computers or mobile phones, right? But there are some things that are special in the IoT. So we will go briefly through the problem with the security. We'll discuss some basic concepts, and then we'll discuss how to minimize the risks. So in general, there are two factors that you may want to consider. The first, it is IoT security that is about two things. First is security of the data, and the second thing is that we make it separate, which is also related to, it's keeping the privacy of the data. In general, first, the IoT is a mass-scale problem nowadays. There are definitely more smart devices than human, and there are definitely more smart devices than their computers, which in practice means that it's a magnitude higher scale with those devices than what you face regarding, for example, trying to steal your personal data or hack your system or do some random ransomware on your PC computers. If you think how much data is generated, then here you have a scale. Somewhere in 2005, around 500 terabytes of data was daily inserted, created in the Facebook. 500 terabytes per day, that was 2005. But that was actually the beginning of the Facebook, right? So, petabyte is an amount of the data that the CERN Large Hadron Collider generates per second. It's petabyte. The digital universe, as for 2015, it was around 250 trillion of DVDs. Those standard 4.7 gigabyte, right? So it's yottabyte. Brontabyte is the universe by 2020. Around we are 2024. We are close to gigabyte scale of the information we need to handle. And first, there can be somewhere ghost in the machine, and this data can be already compromised that we are even aware of it. So we'll talk about this later. And the second is that actually we generate so much data that we are no longer able to control it manually. What we need to do is just to use either artificial intelligence or automated tasks just to analyze this data and also to check either in this scale this data is being compromised or not, which is not so easy. So here you have what happens every minute, but honestly, this is the data for 2015, which is 10 years ago almost. So I wonder if you know it, but for every minute of the day, there's around 600 new websites created. For every minute of the day, users add around 3,000 photos to the Flickr. For every minute of the day, in 2015, there were around 3,600 shares new images in the Instagram. Every minute, come on, not every hour, every minute, right? Apple had around 47,000 application downloads every minute. Twitter users were sending around 100,000 tweets, which is nowadays, as I checked, it's 10 times more. So every minute is over 1 million of tweets. Every minute, which means 24/7. YouTube users uploaded in 2020, 2015, around 40 hours of video content every minute. Now, how to watch it, right? You can't. A number of emails, that's another story, but surprisingly, a number of emails is constant for a time, because emails are no longer such a popular. It's mostly corporative stuff, but the young generation has replaced it with the boot and chat communication, right? So a number of emails is not growing that fast, right? So interestingly, the amount of WordPress publishing posts or comments was quite high that days. Nowadays it's even higher. So see, here you have maybe imagination what is the scale of the data generated. I'm not telling that this data is generated by IoT. No. Partially, yes. Partially it's automated. Partially it relates to the IoT. But obviously not all of this data is sent by the IoT devices, just a minority. However, this chart, it doesn't represent the synthetic creation of the content, which is mostly to the IoT. Okay, let's focus first on the data lifecycle in the IoT. What I want you to generally tell is that somewhere on the edge, we have an autonomous online device, which obviously is identifiable according to the IoT principles. And it produces some data, like, think about like a sensor network. So you have, for example, a temperature sensor in your room. It goes for the in-network processing, which we already discussed regarding the networking, right? We said that we need to aggregate the data, maybe make the packets longer because the internet doesn't like short packets. Then we store, upload it, deliver it somewhere to the top application services. But obviously, on the front-end approach of the device, we also can collect the data and present it to the user, eventually aggregate it and deliver it again to the front-end. We also have a pod that is usually implemented in the fork, which is in the middle of the screen, which means here you can pre-process the data, store, archive, and analyze. It all has an impact regarding the design of the security, because there are three layers, like in perception, processing, and the cloud part. And each part of the system has a slightly different requirements and slightly different threats. So the scale is like edge class devices, which are those end nodes. There are billions of them. Fog class devices, you can consider it like a millions, right? Those are those gateway routers, protocol converters, services, but the mass scale services, for example, one service for all the sensor network or the communication broker, right? It's a good example here. And finally, you can think about the data centers or the cloud. We call it cloud, which are thousands of them, right? So each scale is like a magnitude higher. Billion, million, thousands. Let's define IoT security as it is. So first, information security has three major concepts. First, it is confidentiality. So it means that only authorized user is accessing the data. Data is confident. No, the persons who are not intended to access the data shouldn't be able to do that. Second, it's integrity. So it ensures that this data is complete, which means that the data itself and the processing of the data has not been compromised. So in other words, you can rely on this data. And third is accessibility, which means that you can access this data when you need it or when you're expected to do that. Can any one of you tell me a good example when accessibility is broken? It's all kind of denial of service attacks, right? Yeah, exactly. So all kind of, for example, denial of service attacks. They disable the system. This is the kind of lack of accessibility. Okay, so safety of the information is the status of the security of those three above. So data is safe, if it is confidential, it's integrated, and it's accessible. Once we have the definition, let's go to following. Risks and threats. Well, what is a risk and what is the threat? And the vulnerability. So in general, threat is like a real or potential danger of making an act against our data. So it can be an act which is active or passive. Active is that you do, for example, modify the data. And passive is when you disable the service that is supposed to modify the data, but it can't right now, right? So it's directed against data security, and it's causing a damage of at least one to those factors that we defined previously. Either it's confidentiality, accessibility, or integrity. You may experience here misinformation, loss of information, or distortion. Now, what is the vulnerability? It's an error implementation or design that is causing that someone can access your system and compromise the data. So, make a threat, in other words. It can be voluntary or involuntary. So the risk of the information security, it's a possibility that the someone, like a threat or something, because we can also think right now about an AI that is potentially smart enough to break and make a threat. Someone and something, some system, some person, is able to use some vulnerability to cause damage to the data. So there must be two factors, right? First, a possibility to do something bad, and second, someone have to use it. Just a possibility is not enough. I bet that there are thousands or even billions of vulnerabilities that have never been discovered. When there comes a threat, then this is the potential problem with the security of the information. You can find a list of IoT security incidents in this note, in this list there. Okay. So, IoT is like any other digital system, no doubt. It has some sort of constraints, but still we can consider it like a computer, right? On any level of IoT infrastructure. First kind of hacking is a device hacking. I mean here by either even hardware hacking, like you add something for a device. I will give you an example, maybe not related to the IoT, but it will give you understanding. I wonder if you know, but for a long time, American NSA was using supermicro computers, like their servers, because it was considered to be a safe company, owned fully by US citizens, not Chinese. At some moment of time, like everything else, it was sold and started manufacturing in China. And I wonder, CIA perhaps, they discovered that majority of their servers, they have some additional hardware built into the motherboard that was not designed, not in the original design. And it's like, for example, a microphone, which doesn't make big sense, but anyway. So you can read about this in the Supermicro hacking. That was a sort of the hardware hacking that Chinese manufacturer added some backdoor, perhaps, on the hardware level, right? They modified hardware design. If you break one on system on chip or operating system level, which is then the software, that usually means that you break all the devices. This is very dangerous. If you make a vulnerability this way, you're able to inject the vulnerability, it naturally affects all the devices in the mass scale, which are manufactured in millions. Either it's in hardware hacking or low-level operating system software hacking. And this is a very, very dangerous because first, unauthorized access to the firmware code, either it's on the source code or the binary, because you can also decompress the binary and modify it, On the development stage, like for example, injection of the malware, backdoor, and the vulnerability, it automatically causes people to update this firmware. And it spreads naturally over the channels that you have no idea that actually you are seeding fake or broken firmware, right? Moreover, it can be used easily then to make a distributed denial of service attack, because you have plenty of the devices and they're just waiting for ignition signal. Distributed denial of service is very problematic because it's really hard in the beginning to distinguish it from the natural activity, because the requests come from the different part of the network, from different part of the world, but they focus on the single server. This is how actually hackers usually put down some selected services like banking systems or railway systems, right? We had it like last year, I believe, in Metropolis, this communication system, all the this information displays on the bus stops, they were down, right? Because they were hacked, right? So they did it on a mass scale. So you can create like a fake or broken firmware with the vulnerability, but it may also happen like do it on the runtime. However, breaking in on the runtime level is a little bit less efficient. Why? Because you need to hack individual devices. Of course, you can do it in the mass scale if you know the vulnerability. But for example, you may use the most common mistake that is done by the developers, or actually, sorry, introducers of the system, like an implementators, which is lack of the approach towards politics of the security. For example, they do not change the default user and the password, right, which is on install. They just forget it to change. But some of them will do, so then you cannot access those devices, but you can access others, right? So hacking on the firmware level is very, very efficient, but it's also problematic. On one hand, on the other is quite easy. Depends again on the approach of the manufacturer. Let me explain. I bet like 99% of IoT devices, they base on the publicly available libraries, which usually come from GitLab. Bet that companies want to have a short time to market, so they do not analyze the code like every single instruction in the source code. Just get a ready library, they include it, and they are happy it works, right? I think you understand the problem now. Because if someone puts some malicious code into the library, it may be never discovered that it came this way. Another thing is that many IoT ecosystems, they are based on public repositories, even with their source code, right? For example, OpenHub or so on. On one hand, it's dangerous. On the other, I consider public resources as safe. Why? Because there are many eyes watching, so they will easily find if someone had maliciously modified, right? So actually, using open source can be considered in the first approach like a disadvantage, but if you think a little bit more, it's like an advantage, in fact. Okay. Maybe one of the most prominent vulnerabilities that happened to the networking services was infamous TP-Link company, Backdoor. I wonder if you heard about this, but the idea was as follows. They created a backdoor in all their routers in the firmware level, that this backdoor was let virtually any of the, according to their plan and explanation, it was like a backdoor to enter and to give an access to the service, to the support, in case of devices that were, for example, abandoned with a password, or they were bricked, right? I mean, logically bricked, not physically bricked. The idea was as follows. You access the web console with the browser. So usually you need to provide some credentials, like a user and the password, or just a password, or the PIN code, whatever it is. But the TP-Link created a fancy code that was actually checking the browser's user agent string. Every browser is representing itself to the web server, sending its identifier. Either it's like an Internet Explorer, Netscape, Mozilla, Firefox, Google Chrome, Safari, and so on. So they invented some funny string that was actually, when present, the server knew that it's supposed to be service coming, so they never asked for the password, and they have no open access. What the hackers did, they took an original firmware, reverse engineered it, and they found this security key. And that day, when they announced that, it was really enough to make an about config in your Netscape or Mozilla, change your browser identification, and naturally you had an access to all the TP-Link devices in the world, just to know their IP address. Funny. Next level is a communication hacking. What I mean by the communication hacking is IoT devices, they communicate over the network. And on the communication, starting from the edge level, this is the wireless communication in majority. Also on the fog level, sometimes it's a wireless communication. So I'm talking here about maybe not compromising devices themselves, but the data streams on the way. A common kind of attack here is man in the middle. So you have a sender, you have a receiver, like for example you send over the Wi-Fi and you have a Wi-Fi access point, and there comes another device that is in the middle and will intercept the data. You may consider how is it possible? Quite easily. And usually it is because IoT devices are constrained one and they bend this enrollment challenge problem. When you connect to the Wi-Fi, do you really check if the Wi-Fi you are connecting to is the Wi-Fi that is intended to be? Are you on the eduroam right now?
Yeah.
Are you?
Yeah.
Okay. So my personal question is, are you sure it's eduroam or is it like my ESP32 that is transmitting all your data and I can watch it?
I hope it's not.
But you just hope. You don't know it.
Well, we can share our lab results with the world. There's no packet with the certificates.
Uh-huh.
And it was checking the
Okay. But this is actually what majority of the people is not aware, or they are don't care about this. So careless approach, and they will never know. Actually, I did myself an experiment years ago. That I had an office building on the other side, and I just set up with a directional antenna just to have a stronger signal, one of the access points. And what I did was really dummy. Instead of even routing this data into another network, which is just like in case of the man in the middle, I just opened to the user a web browser with please provide your email and your password. And they were so dumb to do it. So I could easily collect the data of the people sitting some 100 meters from me, right? Why? Because they trusted. There was like a blind trust. So again, reckless approach of the users, right? Man in the middle. But man in the middle may be also on the technical level. For example, imagine that the devices, because of the enrollment challenge, they share some login key, right? So you can then easily try to compromise it. If you hack an radio communication using, for example, software-defined radio. Actually, we do it on the masters, so you're welcome to join us. So, yeah. Infrastructure hacking. It's quite close to the communication hacking, but hackers, they take over the network infrastructure. Not step in the middle, but replacing all your infrastructure. As in, your devices may be not aware that something bad happens. But your routers can be taken, right? And the data streams can be either at least monitored and recorded, but in the worst case, they can be modified, right? This is what I would say, the integrity of the data. Yeah. Okay, so types of the vulnerabilities in the IoT now. First, feeble registration data by default or defaults, logins and passwords. Honestly, even in the IoT, which has really limited resources, cannot use very complex enciphering, cannot use very complex encryption keys because of the lack of the either CPU or storage and so on. Even in those cases, the most common problematic part of every IoT ecosystem is human. Administrator, implementer, right? So first, change your user and the password, right? I bet that even at this university here, if you scan the networks and you will find a Raspberry Pi, the first thing you can try to do is SSH at this IP and the password will be Raspberry. Even if they created other users, those default ones will still remain there. Give it a try. Raspberry Pi is one of the most common fog class devices now. Next. Registration data displayed in the network traffic. Oh, you will do it on the labs. Actually, this is secure because we use a separate network and everyone knows this user and the password. However, when you connect to the MQTT browser, you send your data over the network open text. So everyone can discover user and the password. It's not encrypted. Cross-site scripting, it applies to the websites. SQL injection, it applies to the websites. Not only, but in general. Careless control of the session. Honestly, this is what happens, for example, with the COAP, but also with the web browsers. If you direct your web browser towards a banking system, you get a session ID. If the session ID is not related to this particular machine and the user, the session ID can be taken and reused by some hackers just to mimic that they are also in the session. For example, make a transfer from other computer, right? So obviously nowadays the banking systems are designed, they are designed for it, so they can check that the same session ID comes, for example, from a different IP address, right? And then it's like a warning, something bad is going on. So you need to be aware of it. Okay, feeble setting of log and deleting account entry. What I mean here, for example, you have an administrator of the system, like, I don't know, maybe just admin that was introducing this. And your administrator leaves the job, but his account is still active. First, no one will change the password there for a long time, perhaps. Second, this person may be already working for a competitive company, right? So it's like this feeble access of the settings and locking and deleting accounts. Okay, vulnerabilities specific to the network services. First, services vulnerable by themselves. For example, they don't have an user filtering, they don't have an credentials needed just to use it, right? So this is one of the possibilities. Buffer overflow, classical, just to get it broken. Open ports through UPnP. If you wonder what is the UPnP, it's a mechanism that let the devices connected behind the NAT automatically configure the router to make a port forwarding. It is, for example, needed for gaming consoles to have a double-way communication, voice communication. So Xbox, PlayStation is using router's configuration just to reconfigure it automatically. Otherwise, you will lose some services, or perhaps they will maybe limited, or the experiments may be lower, right? So UPnP is good for, it's great for automating and simplifying the tasks for regular users. But unfortunately, it's very dangerous for devices because you configure it per router, right? So then virtually any device can come and tell, I want to open the port and redirect it to myself. And then you don't know either this firewall hole is on purpose or is it for hackers, right? You don't know it. Okay, operational services of UDP. Well, UDP is also considered to be like maybe a little bit less secure because it's send and forget, right? So we can intercept it. And because it's send and forget, you can have, for example, some extra time, like a latency increased for this kind of the communication that you can modify the data, right? One of the methods to identify either there is some threat is to check if the transmission time has increased, right? Because every modification of the data or even monitoring of the data, like man-in-the-middle attack, requires some extra time to process it. So if you observe that it has changed recently, then you may start to suspect that there is a problem with the system. But this is not the case in the UDP because UDP doesn't have any built-in quality of service. It's just like a send and forget it, right? So either it comes in the short or long time, that may be natural. Denial of service and distributed denial of service is actually the result of the threats and the vulnerabilities. So which means that many devices are pinging one service or trying to use one service just to overwhelm its resources and put it down. Most common attack on the mass scale used by hackers. Denial of service comes usually from one device. Distributed denial of service comes from multiple. And what is the problem with the IoT is as follows. A nice technique to distinguish an attack from generic traffic. When humans were using computers, it was just to check either there is some pattern behind this traffic or is it random like human do. The problem with the IoT is that it's naturally generic, very technical traffic according to the sleep work patterns of the IoT devices. So they wake up all, they send some data, they go to sleep. Now, they wake up all, they do denial of service, and they go to sleep. You cannot distinguish those patterns that we used to distinguish the human-generated traffic from the synthetical traffic before, right? Because IoT devices are making only synthetical traffic, majority, not all, but majority. So one of the factors that may be used just to distinguish malicious work from the regular is not working in the IoT. Okay, regarding authorization and authentication, what we can tell here. First, absence of an optimum password policy. For those who are listening in the morning RMF FM today, you may know the most common password in Poland. I cannot tell because I'm recording, but honestly, it's four letters starting from D, and next comes 1, 2, 3, 4. There's a most common password in Poland, as statistically for patterns. Yep. The other is, for example, QWERTY 1, 2, 3, or like A, B, C, D, E 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So those are all the passwords that every hacker will give it a try using some brute force attack, right? Just to give it a try and just to try to break in with the popular passwords. We are only human, right? There's an even famous test that someone asks you that you quickly, without thinking, need to tell device and the color, and majority of the polls will answer it's a red hammer. I don't know why is it, but you can give it in the psychological test. So we think similar way, so we create actually similar passwords. We really do. We are only human, and that is what is used to be controlled by the password policy. For example, you need to have a capital letter, you need to have a special character or two, or it cannot start with a number, or it can start with a digit, right? So this is like a password policy. Absence of two-factor authentication. Okay, that's problematic in case of IoT devices because the IoT device won't get like a Google Authenticator and provide a time-based code. But for users, it is good. Unprotected recovery of the password. Guess, guys, I have seen a system that was actually keeping the passwords, not their hashes, just the passwords, inside their database. And guess what? Password recovery was working the way that you provide an email and it sends you your password. The problem is that actually you may provide any email of the user, so you first, that was an early stage of the web development, so it's something like in 1999 or 2000, but this was the case of unprotected recovery of the password. On the other recovery can be like, for example, not using a tokens, but just generate a password. The absence of monitoring of the access by roles. So what I mean here is, again, if you have in a system, all the devices have, for example, root privileges, right? That's a very bad idea. Because if you break any device, then automatically you have root access to the services, for example. Okay. So, regarding the types of the vulnerabilities, summary. IoT is mostly machine-to-machine communication, so we cannot use as an identifier, we cannot use the distinguish between the synthetic and natural human-like traffic generation. It doesn't work here. But the most common reason for the security breach is still human. Either because of the poor design, either because of the lack of the security on the development process, either on feeble approach to the implementation and then introduction of the systems, right? In most cases, it's just a lack of foresight, right? And care on the IoT system design and implementation. Yeah, still. Okay, part 2 is regarding IoT privacy. So let's discuss about the privacy now, which is nowadays a very hot topic because you daily get a number of spam calls, you daily get a number of spam emails asking you to pay for a delivery that you never has actually ordered, or asking you to pay some small amount, so-called Nigerian fake business, that you need to pay $10 to get 25 million because you're an abandoned, yes, yeah, an abandoned king or queen of some, yeah, prince of Nigeria, yeah. Okay, so with the IoT, it's special because IoT is very personal. I mean, not all of them, but the wearable devices are very personal. They know far more than you can expect about you. A number of the sensitive data, sensitive I mean personal, it grows. 20 years ago, no one was watching their heart rate 24/7. Nowadays, those who wear smartwatches, they do, for whatever reason. Generally, all those aforementioned threats and vulnerabilities, they are subject of possible break of the privacy also, right? Because if someone is able to access the data, it can be like a temperature in this room, so it's not very worthwhile. But in case of, well, your personal information about the health, it would be very valuable for insurance companies to know it, right? There's a number of ways that IoT developers can improve IoT privacy. So, as we discussed, we commonly share our personal information. For example, you are tracing your data with a mobile phone and you don't want to share your location, right? But actually you do all the time. You are with your mobile phone now, and even without the GPS turned on, using some simple triangulation that works mostly in the city centers, you can find your mobile phone with accuracy of up to 50 meters. So then your boss knows that you are not where you're supposed to be, for example, right? It's personal data. So what to do to minimize this, these threats and these vulnerabilities? First of all, IoT devices shouldn't record or collect more data than it is necessary. If your device is intended, for example, to check your location, like approximately, it shouldn't do it with a high accuracy. Second is minimize a number of data sources, because data aggregation that is done in the IoT device can spread across different source domains the information if unauthorized access to the device is granted. What I mean here is if your system is already pre-processing some information from different sources, then then you should keep those sources as minimum as possible, not to make them redundant, not to make them, for example, discovering more data than needed. If you don't collect this or use it, if someone breaks into your device, it may be used in some other ways that you actually intended, right? Minimize raw data collection. What I mean here is, if you collect raw data, then processing of this data by the way you designed it and by the way that someone will use it may bring you totally different results. Maybe those that you don't want to share, right? What I mean here is, for example, you record your heart rate, and then you just check either you are healthy or not. But someone may use it to check either you are training or not and increase your insurance policy payment because you are considerably having heart problems in the future, right? Because you are not doing any sports, because your heart rate doesn't rise up. So that can be recovered from the raw data, right? Same data, different results on their analysis. Minimize knowledge discovery. So again, this relates to what I said before. The devices should have like only to do the purpose they were intended to do. So for example, just check the only check this heart rate for to inform you either it's okay or too high or eventually too low, but not to do any extra analysis that this device is not intended to do, right? Keep short data retention period. Don't keep the data longer than necessary. For example, again, heart rate. If an analysis requires, for example, a heart rate from last hour, and that's enough just to tell either something bad is going on with your heart or not, don't keep the full data since your device was initiated, because if someone breaks in, it will have like a 1 hour data, but so this is useless for example, for the insurance company. But if you automatically will, when some threat is and the vulnerability has been used, and someone breaks in, they may recover all your data, for example, for the last 5 years. Then it's not good, right, for you. So, yeah. Minimize data row storage. I mean here, you should, if you need to keep the data, try to keep it depersonalized. This is, for example, with the passwords, right? The common strategy to keep your password is not to keep the original password the user provides, but rather to use a hash function and keep the hash function. So you have a hash function in the database, and then when someone logs in, you calculate using the same algorithm and you compare the hashes. Having a hash, you cannot recover the original password, so you don't know it, right? This is how they do it in majority of the web systems, and this is how it could be kept, right? So don't keep the original password, rather use its hash. If this is one directional function, like a hash function, that's fine, right? Because even if someone recovers your hash, that's useless. Unless you use the rainbow tables, but that's another story. Support hidden data routing. You know, in the IoT, it's quite common that the devices share data processing because the devices, they have constrained resources, so the data processing can be shared. Now, if you can make it universal, like in the Industry 4.0, and the devices can switch or change the routing, for example, this part has been processing here, that part has been processing there, but in the next round they swap their duties, or even change the routing, it's fine, because someone who breaks in on the networking level will really struggle to find out what actually is going on inside, right? Because it changes every couple of minutes or seconds, right? This is the common problem actually even with hacking the GSM. I wonder if you know it, but you can easily hack, for example, in SMSs. It's doable. Unless you have a data hopping. And this is the common strategy. You change the frequency, you change the channel, so you will need to follow. Part of the information is sent on one frequency, part of the information is sent on another. And then you need to have a really smart hardware just to follow it. And you don't know the changing algorithm, so you have to recover first how it changes, to which frequency, right, and when. just to follow and recover full information, and based on that recover what's the content. Now, encrypt data communication. It's natural. I think we don't need to discuss it here, right? But still, please remember that in case of the IoT devices, this encryption of the data is problematic sometimes, because you cannot use in those end node devices that are solar powered, you cannot use very complex encryption algorithm because they will run out of the resources easily. Encrypt data processing. Yes. Any one of you heard about quite interesting method of hacking your computers, your Windows, how to recover your password years ago? When you have a physical access to your laptop, it may be locked, it may be hibernated. The only need is that the password is stored right now in the RAM memory. You take a liquid nitrogen, you spray this liquid nitrogen into the DIMM memory chip, you physically remove it, you keep it in cold, and then you bring it to another computer and they're able to recover contents from the RAM. Now, if the password was not encrypted in the RAM, which you consider would be safe, right, because it's my RAM and my computer, then you're done because they know your password. For example, for this reason, many of the frameworks, I know the .NET, but for example, for sure Java, PHP, and others, they have something like an encrypted string, which encrypts and decrypts the content stored in the RAM. Okay, reduce data granularity. So that was what I told you before. You shouldn't have more accurate recording of the data than is needed for the purpose it was intended to, right? Query answering using preprocessed data. So do not send raw data. Just use preprocessed. For example, you can imagine it like, for example, if you record the personal data, you have some sort of the identifiers that you have attached to every person, not their personal ID like PESEL, right? Just use.
Example of that is that Samsung had a leakage of data because some of the developers used ChatGPT and didn't change the data inside. They just gave in the Samsung data.
That could be, yeah. But actually, in this case, regarding this data granularity, this preprocessed data, it's not the personalization of the data, but it's rather like changing an ID. So you may be right? Because if they were asking ChatGPT, they could ask like a user 1, user 2, user 3 instead of regular emails or whatever they use, right? So yeah, this is the case. This is the case. Just to use the personalized data. But in a real system, sooner or later, you have to repersonalize this data, for example, in the cloud, to let it meet your user ID. So imagine, for example, that you have a smartwatch that's recording your data, but it doesn't know your personal data, just a unique ID. And the binding between this unique ID that is sent along with your data, according to the databases somewhere on the cloud, it then reflects your real data and binds with your account, which is more safer, right? Because the user will see, okay, there is some user identifier and some data. Unless they have a second part, which is cloud part, they do nothing with it because they don't know who you are actually, right? Block repeated queries. Yeah, multiple querying should be blocked as it may suggest a threat to violate user privacy. So if you observe that there's a service, IoT service, and you have a common request and another one, this is how we just block the brute force logons, right? If you try to log in a couple of ways, your account is usually blocked, at least for some period, or you need to unlock it some other way. So yeah, that's natural. Distribute data processing. Well, if someone breaks into the data processing, then they may be able to observe all the data. If you have a distribute, either on the record level or either on the, let's say, entity level, then it's even better, right? If you're able to do that. Distribute data storage, again, if someone breaks in and they are able to access your storage. If it is unencrypted, it is all in one, then they have everything. Perform knowledge discovery on aggregated data, not on the raw data, right? So do not try to keep this data, like for example, you send a shopper's GPS location based on the IP address or whatever, right? If you just need to know that the buyer is from Poland, just send it, it's from Poland, not from this particular city. Yeah, because later on someone may find out that, for example, they have a data from another resource, for example, from the credit card banking system, that they knew that the transaction was done in this particular shop. And based on the name, they can bind it together and know exactly who you are and what you buy. Disclose information to the user. So the data source should be like a transparent. The user should be aware of. Well, we have this GDPR policy, right? So that's usually taken. Either you're reading it or not, that's another story, because it's very, very complex. But at least you have, by law, you have an ability to be, as they say, forgot by the system, right? So we can just like opt out from the storing your data. And obviously, log activity. That's really important. Why? Because if you don't log your activity, then you may never recover that your system has been compromised. I mean, the biggest problem with any computer system is just to find out that something wrong is going on, right? You will never know it. Now, a couple of more hints. First, perform periodic audits. So, for example, if you have an IoT system that has been set up and you're happy it works, okay, but please give it a audit from time to time. It's not enough it works. The question is how it works, right? If something has changed over the time, for example, longer transmission times or the bigger bandwidth use, right, that may suggest that something is going wrong. Keep application source open. Well, we discussed it previously, right? So it can be like an advantage and also disadvantage, but in majority, I consider it like an advantage to have an open source, because then community can find vulnerabilities on the code level. Create the documentation, right, that presents the data flow, because later on, if you're a designer, an implementer, an inventor, and also someone who makes an introductory system, then perhaps your approach is again, from the psychological problem point of view. Then your approach may be wrong, but you will never discover it, because we are only human. But if someone else comes and can see a diagram of the data flow and can say, okay, you can have a potential threats here, vulnerabilities, sorry, here, here, and here, right? Please change it.
There's even like the work to be because developers are
Yeah.
trying to make everything safe,
Yeah.
and they do it wide, and the hackers trying to just one.
Yeah. Yes, yes it is. This is why the companies sometimes even pay for the people who find the vulnerabilities. Yep. Okay, go for certification. That's similar to like an open source, but on the professional way, right? So they can check either your system is safe or not. Use industry standards and go with some policies and regulations. For example, this password policy can be, right, or just a password expiration policy can be word of check and here. So, couple of the security ideas, how to introduce it in the IoT systems. First, some facts about mostly end node devices, which I mean edge class. They present constrained resources, CPU, RAM, storage, but most of all, energy. Those devices, for example, they used to have sleep patterns, which means they go to sleep, which means that they need to reauthorize to the network again. So if those devices reauthorize the network, it is much more vulnerable for man-in-the-middle attacks, right? Because you send some data periodically, which is your ID, access key, user password, and so on to authorize. Devices should be uniquely identifiable. And that's natural because we know in the IoT everything should be uniquely identifiable. But here in the context of the security is even more important, because what I mean here is you need to consider that the devices may use this ID, unique ID, to be their access key, right? Random number seeds should be divergent across IoT network. Not sure, but I think like you're the students that already know how the random number generator works. So you know that if you use the same seed, you will have the same order of generations. So if you use them in all the devices, it's predictable. Yeah. So if you use same seed in all the devices, it's predictable. How to get a different seed in the IoT devices? The simple is to use analog to digital converter. There's always some noise. And it's different for many devices because it depends on the location of the device, whether the moment you start, some inference. So this is a really good idea to make like a blind read from the analog to digital converter on the unconnected GPIO, which will bring you perfectly random value, and that can be used as a seed, right? And finally, there is a number of chips, modules, and the devices that they support security tasks. So let me show you some of them. First, trusted platform model. You know it from the PC computers, right? It can be also implemented on the hardware level in many IoT devices. Trusted platform models is a chip that they contain, first, random number generator, second, safe storage for hardware, hardware storage for a key, like a public-private. They usually have a unique RSA key built in, so you can use it. And they also have a secure generation of the encryption keys if you want to. And they are available as a chip. You can make your own hardware design, or as a model you can connect to with some communication standards like serial, I2C, or any proprietary protocol. Secure crypto processors, HSMs, hardware security models, in other words. Those are embedded sometimes inside the microcontrollers, like in the case of the ESP32, and sometimes they're included like external either chips, modules working over the GPIO, or even on the USB, like a plug-in sticks, but then you need a special driver to the operating system. So for example, they provide you an hardware accelerated encryption and decryption. You can think about it like a graphical card, but for security, right? Obviously not so complex. So they give you, for example, an hardware AES. They give you, for example, hardware-based MD5. They give you hardware-based RSA, right? Different algorithms, different implementations. This is the inside of the ESP32 chip, which we probably you have seen it already on the hardware part of the IoT, but I would like you to pay attention here. This part is for the security. So it's like a cryptographic hardware part. It's hardware accelerated, and as you see, you have a RSA, you have a random number generator, you have an AES, and SHA, which is a hash function. So, constrained devices, they may use a dedicated hardware implementation for ciphering because it will be much more energy efficient and faster. Network interfaces, they used to be equipped with more powerful processors than the main IoT device sometimes. So they may implement a security mechanism inside the network processor, if any, separate. Now, firmware update should be done only through secure channel and with a special care, right? Just not to let in some intruder. Infrastructure should be a subject of regular audits and monitoring. Interestingly, in many IoT large implementations, we put something we call honeypot. A honeypot is a device or a computer that is intending to attract hackers because it has low security introduct. And the approach here is just to attract hackers to use this device. This device is usually recoverable, so let them focus on this particular device, try to hack it, while this device is separated from actually the IoT system. But it intends to be attracted. So this idea is like just to try make a honeypot to take a bees there, right? To come, or a bear, to come to it, instead of focusing on your real devices that are like, for example, critical part of your system. So we call it honeypot. Okay, discovery algorithms for early deviation and synthetic network traffic should be implemented in the network, subnetworks, to shut down the node in case of the suspicion for compromise. So just make it observed if anything has changed, and it shouldn't happen, right? Obviously, if you update the firmware, perhaps the communication pattern can change. But if it changes over time without any updates, it's something wrong with it, right? So either your device is already doing some denial of service attack, or someone is trying to break in. Well, it could be anyway. So you just need to make logs and just to make an analysis. But the good news is actually AI helps here to analyze it, right? So you may try to find out patterns using an AI mechanisms. Okay. Secure communication should be introduced when possible. Okay, security by obscurity doesn't work. We know it. Logical separation of subnetworks should be introduced where it is possible. So, for example, to separate critical part of your systems from non-critical ones. If someone compromise one network, they may not compromise all your networks, hopefully, unless you use the same administrator password, right? So then you shouldn't. Critical infrastructure should be considered as a subject of the physical separation. For example, if you have a nuclear power plant controller, I would never ever connect it to the internet, right? It should be physically separated. Just no one can get in. And obviously any kind of the communication, best would be paper-based, or excluded, but sometimes you bring something on the USB stick and it can be also a threat, right? So we have to be very careful here. So, a couple of hints for the labs. MQTT should be used over encrypted connection, if it is possible, but we won't use it here in the lab. We will use raw plain text because the network is separated, so it's safe. And actually, anyway, everyone knows the password because it's publicly available on the website. So. COAP can be done with DTLS ciphering, so you may use the COAPS protocol instead of COAP. Right, and this is actually the end regarding the theory. Now let me show you interesting practical part, okay? So, this is the article from the Ars Technica. A part of almost every ecosystem is an interface to the human. A very popular one is those voice-based home assistants. You know Alexa, you know Siri, you know Samsung Bixby, you know Google Home Assistant, Cortana, right, from Microsoft, and there are many others. They base on the small devices with the software, and actually they use like a MEMS microphone that is also part of every mobile phone and laptop. Do you know that if you make a laser beam into the membrane of the microphone and you wave the laser beam, the microphone will read it like a speech, but you will hear nothing. Watch this. Do you know it affects all your mobile phones actually you have?
Making things worse, light commands can be mounted easily and cheaply, even using regular laser pointers. This can even be done from far away, for example, between two buildings. Even more worrying, once an attacker has gained control over a voice assistant inside a phone, tablet, or smart speaker, they can use it to break other systems. For example, the attacker can control smart home switches, make online purchases, open smart garage doors, remotely unlock and start certain vehicles, or open smart locks by brute forcing a user's PIN number. So how can we defend against light commands? Well, the basic vulnerability cannot be addressed without expensive microphone redesign. We are collaborating with Amazon, Google, Apple, as well as other vendors on defensive measures. If you would like to know more, check us out at lightcommands.com.
Okay, so watch this. Obviously, it's on the short distance.
Okay, opening.
But you hear nothing. No one is speaking. Let's go a step further. An attack through the window.
Okay, opening.
Now, my question is, did you know about this? Not much. Okay.
I know about the laser microphone. Like you can point laser to the window, because when we talk, the glass will vibrate, so we can like microphones that can hear what's going on.
Okay. One more example. A cheap ESP8266 that costs Node MCU, the most popular. I have plenty of them here. They have a Wi-Fi. Nah, no. This is not. I was thinking about this Bluetooth ones, but here I'm talking about this development board because actually in those drawers here, I mean in those storages, there's an IoT lab behind it, so an old generation one. But I want to show you something. Okay, because the language of the guy is quite hard to understand, so let me explain you how it works. And the ESP8266, even if it's like a small, not so much powerful device, which is just like an old type microcontroller that has a built-in Wi-Fi service for 2.4 gigahertz only, but the new one they have for 5 as well. What they do is they're able to generate tons of the same access points with the same ID. And they can easily overwhelm advertising capabilities of the routers. Thus, block them to accept new connections and even drop the existing ones. It's one kind of the attacks, actually denial of service of your Wi-Fi service. Now, new routers are having some mechanisms that are protecting against it. But if you find something like a 2, 3, or 5 years old router, you can easily block it with having just this device. You need just to be close enough between the router and the user, right? Or closer to the user. And you set up something like 100 access points or 1,000 access points, and your device is helpless because it even cannot scan them all, right, in this short time. The other way, using this firmware, is just to send deauthorize. So you send a deauthorize frame. Many devices can then drop the connection, and then they cannot reconnect. So this is another technique that you can just shut down the connections on the Wi-Fi. Yeah.
Another question concerning the microphone.
Yeah.
Because I'm using iPhone,
Yeah.
so I have Siri in the phone, but I have disabled it.
Okay.
So is it possible that the laser can activate?
Well, in this case, the service is not working, so you shouldn't consider it as a vulnerability. If you successfully disable it, because my question is, can you really something successfully disable in Apple? I'm not sure about this. But if you are sure it doesn't work, then it's fine. I mean, this is also the case that, okay, let's be honest. To make a disaster, there is always a number of factors, right? Not just the one. There needs to be a vulnerability, there needs to be a threat, and they need to meet together, right? In your case, I would say you minimize the risk. So you can, yeah. So you can consider it as safe. Yeah, welcome. So you can look for this firmware. It's available on the GitHub, actually. So you can easily find the firmware for that one. It's only for educational purposes, so I don't ask you to make any nasty things against your friends or family or even enemies, but just for the educational purposes. So as you see, you can do deauthoring or this evil twin attack easily. So that is supposed to be quite a working one. So what I want to tell you now is you never know when the threat comes from. You didn't know about the laser voices for the microphone. You didn't know that the single chip for $2 can do it, right? They can do it. So the world seems to be far more danger than it is, right? Because you can consider your Wi-Fi is solid rock because you have a MAC filtering, you have a firewall, you have a fixed IP addressing policy, but then someone with a small device can shut you down. Yeah. It's maybe not lack of the foresight, but it's just a way of tracing. And the most of all, the biggest problem right now is to find out that something is going wrong, either with your computer or the IoT, because the systems became so complex and so unpredictable in terms of their timings, load, run, and so on, that you never actually know either a computer is, for example, digging the bitcoins on the CPU because someone broke in, or is it doing a Windows update? Isn't it? Yeah. So things are quite complex nowadays.